Welcome back to Mr. Vaughn's classroom. Please take a moment, hit the subscribe button so that you'll be notified anytime I add new videos. And if you find this lesson helpful, please give it a thumbs up to help the algorithm. Today we are in Unit 4 on functions. This is the start of the second half of the unit after the mid-unit test. So Lesson 10 is the first part looking at domain and range. Our learning goal today is to find all possible inputs and outputs for a function. We have two learning targets today. So as we go through practice problems, please keep these two things in the front of your mind. And if at the end of the lesson you're not comfortable making either of these statements, then please leave a comment and I will get back to you with any help you need. Learning target number 1, I know what is meant by the domain and range of a function. And what we mean by that is you need to be able to associate domain as being the x values that are allowed to be input, and you need to associate range with being the y values that are going to be allowed to be outputs. And learning target number 2, when given a description of a function in a situation, I can determine reasonable domain and range for the function. So if you are given a description, a word problem, you're able to logically think about what types of numbers are going to be allowed to be inputs, and therefore what types of numbers are going to be allowed to be in your domain, as well as logically understand what type of numbers are going to be allowed as outputs and therefore would be allowed to be in your range. Because mathematically, you might be able to take any number. Logically, sometimes numbers don't make sense. Sometimes you can't have negative numbers. Sometimes you can't have partial numbers. So you've got to be able to logically think about these problems and narrow down exactly what types of numbers you're going to allow in the domain and exactly what types of numbers could come out in the range. We've got two glossary terms today. The first one is domain. You're going to see this term a lot. You need to make sure you understand what it means. And the domain is simply all of the numbers in a set that you are going to allow to be inputs or the x value for your problem. So think, can it be partial numbers? Can it be negative or positive? What types of numbers are you going to allow for your input? And those numbers are going to be your domain. Our other glossary term is range. This is going to be your output. What type of numbers could be allowed as far as output or y values are concerned? Are my outputs going to have to be whole numbers? Are they going to have to be multiples of something? Are they allowed to be partial numbers? Do they need to be positive or can they be negative? These are things you're going to have to logically think about in the context of the problem that you're getting to determine what types of numbers are going to be in your range. Now we can start with the practice problems on Unit 4, Lesson 10, Domain and Range, Part 1. The cost for an upcoming field trip is $30 per student. The cost of the field trip, capital C, in dollars, is a function of the number of students x. Select all the possible outputs for the function defined by capital C of x equals 30x. So a few things that I want to point out before we get started solving this. Remember, any time that I see the words is a function of, that tells me whatever comes before those words is the output. Whatever comes after those words is my input. And you'll see right here, they're telling us that the number of students is x, which is our input. Now, we care about all the possible outputs. So we care about the cost. Now you have to think, what type of numbers could be the inputs? Well, I know that my input is number of students. So I could not have negative students. I could not have 0 students, or there would not be a field trip. So it's going to have to be positive. And I know that I cannot have partial students. These are going to have to be whole numbers. So my input has to be positive whole numbers. Now I have to think about what type of outputs these inputs could turn into. So my output, if I take a positive whole number and I multiply it by 30, then I'm going to get positive whole number multiples of 30. So one student would be $30, 2 students would be $60, 3 students would be $90, and so on and so forth. So now I need to look through my choices and see which numbers meet this criteria. So if I look at A, that's 20. 20 is not a multiple of 30. It's in between $0 for no students and no field trip and $30 where it would be 1 student. B is a multiple of 30. This means we would have 1 student. Choice C is 50. 50 is not a multiple of 30. So our choices would either be $30 at 1 student or $60 at 2 students. We couldn't have anything in between. Choice D is 90. 90 is a multiple of 30. This would be 3 students. So D is a possible output. And then our last choice is 100. Well, we just saw that 3 students would be 90. If we go to the next, which is 4 students, that's going to be 120. There's no possible way for us to get 100 as an output. So this is what we're talking about, where you need to understand not just mathematically what numbers you can get, but logically what type of numbers can you get. And since your input is going to be number of students, you could only have positive whole numbers. and therefore multiplying any positive whole number by 30 is going to result in a positive whole number multiple of 30. Therefore, my outputs have to meet that criteria. If you have any questions about how to determine the logical criteria for your inputs or your domains and your outputs or your ranges, please drop a comment below and I'll get back to you with any clarification that you need. Our next practice problem says a rectangle has an area of 24 centimeters squared. Function f gives the length of the rectangle in centimeters when the width is w centimeters. Determine if each value in centimeters is a possible input of the function. So, a couple of things to make sure we understand before we solve this. First, anytime I see function f gives, it gives the output using the input. Also, we need to understand that when you see area of a rectangle, the area equals the length times the width. So what they want to know here is what types of numbers could be the width in order to find the area of these rectangles. So we're trying to figure out what types of numbers are able to be widths of rectangles. And so when I'm trying to figure this out, the width of a rectangle could not be negative. If it was negative, there wouldn't be a rectangle. The width also couldn't be 0 because if it was 0, you would have a straight line, not a rectangle. So we know that the width has to be positive. But something that changes with this problem is that now we don't have to have whole numbers. I can have a rectangle that is 3.5 centimeters wide. I can have a rectangle that is 4.2 centimeters wide. We can have partial centimeters. So the only thing we need are positive numbers for the width. So now we start looking through these. 3 is a positive number. That could be the width. 0.5 is a positive number. That could also be the width of a rectangle. 48 is also a positive number and could be the area of a rectangle. -6 could not. There is no rectangle if I have a negative width. And 0 also could not. Because if I have 0 width, I don't have a rectangle, I have a straight line. So any of these are possible answers. If my width is 3, then 3 times length equals 24 means that my length is 8. If it was 0.5, then 0.5 times length equals 24, and my length is 48. And if 48 were my width, then 48 times length equals 24, means my length equals 0.5. All three of those are possible. The main thing we need to understand is the logic behind making this decision. I know that I need to find a width. Therefore, I know that in order to actually have a rectangle, that width needs to be a positive number. So any positive number is a possible input for this function. If you have any further questions about this, please drop a comment below and I'll get back to you with any help that you need. Our next practice problem says select all the possible input-output pairs for the function y equals x to the third power, or x cubed. Couple of things to make sure we understand before we start trying to solve this. Remember that a point pair is written with x first and y second. Also, remember that x cubed equals x times x times x. So now, what we need to do, in order for one of these point pairs to be true, we need to be able to take the first number, multiply it by itself 3 times, and get the second number. So for A, this would be -1 times -1 times -1. -1 times -1 would be +1. And +1 times -1 would be -1. So A is a possible input-output pair. Now we look at B. We would take -2 times -2 times -2. -2 times -2 becomes +4. And +4 times -2 becomes -8. -8 is not +8, so B is not an input-output pair. Choice C. We're going to take 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 27 is not 9, so C is not a possible input-output pair for this function. Choice D. We're going to take 1/2 times 1/2 times 1/2. 1/2 times 1/2 is 1/4. And 1/4 times 1/2 is 1/8. That matches the y value, so D is a possible input-output pair for this function. Choice E. We're going to have 4 times 4 times 4. 4 times 4 is 16. And 16 times 4 is 64. That matches the y value in E, so E is a possible input-output pair. And our last choice, F, we have 1 times 1 times 1. 1 times 1 is 1. And 1 times 1 is 1. That does not match our y value of -1. So F is not a possible input-output pair. If you have any questions about how to take a function and identify whether given point pairs are possible solutions, please drop a comment below and I'll respond with any help that you need. Our last practice problem: a small bus charges $3.50 per person for a ride from the train station to a concert. The bus will run if at least 3 people take it, and it cannot fit more than 10 people. Function B gives the amount of money that the bus operator earns when n people ride the bus. Number 1, identify all numbers that make sense as inputs and outputs for this function. So first, we need to notice that the bus will run if at least 3 people take it and cannot fit more than 10 people. That's going to be our input. So for number 1, the input is between 3 and 10 people. If it's any less than that, the bus won't run. And if it's any more than that, it can't fit the people on there. So this is going to be our domain. Next, we need to identify the outputs. Well, here we need to take one more piece of information. It's $3.50 per person. So it'll be between 3 people times $3.50, which is $10.50. And the maximum, which was 10 people, times $3.50 each, which comes out to $35. So we know that our domain, or our inputs, is going to be between 3 and 10 people, and we know that our outputs, or the range, is going to be between $10.50 for 3 people and $35 for 10 people. Now number 2 wants us to sketch the graph. So we need to keep in mind, this is not going to be a line that we draw because we cannot have partial people. We cannot have any amounts of money between the multiples of $3.50. So that first dot is going to have to go at 3 people, $10.50. Now we know that our maximum was going to be at 10 people, and that was going to be $35. And in between, we are increasing $3.50 for every person. So $10.50 plus $3.50 is going to put us up at 14. 14 plus 350 is going to put us up at 1750. 1750 plus 350 is going to put us at 21. 21 plus 350 is going to put us at 2450. Plus 350 is going to put us at 28. Plus 350 is going to put us at 3150. And then finally, $35. These points create our graph. We will not have any points before them because we cannot have less than 3 people on the bus, or it will not run. We cannot have any points after this because they cannot fit more than 10 people on the bus. And we will not connect these points with a line because we can't have any dollar amounts in between. Our dollar amounts must be multiples of the $3.50 per person. If you have any questions about any of the practice problems we've done here on Unit 4, Lesson 10, please drop a comment below and I will get back to you with further clarification. To finish up this lesson, I want us to go back and look at our learning targets again. Learning target number 1, I know what is meant by the domain and range of a function. Remember that the domain is all the possible inputs or x values, and the range is all the possible outputs or y values. If you have any questions about that, please drop a comment below. Learning target number 2, when given a description of a function in a situation, I can determine reasonable domain and range for the function. Remember, there's a difference between what is mathematically allowed and then what is logically allowed based on the individual situation. So if you have any questions about how to determine what numbers should or should not be allowed in the domain or the range, please go ahead and drop a comment below. Thank you for joining me in this lesson. Please hit the subscribe button if you haven't already so that you get notifications anytime I put one of these out. If you found this lesson to be informative, please give this video a thumbs up, and I look forward to seeing you in the next lesson.